Hello friends, this is Durga from ITversity. So this is actually Big Data introduction session for CSC, Computer Science Corp. So you will not be able to chat or anything, but you can listen. This is primarily backup for them. Okay, so we will start as and when people join from the company. We will take it from there. So please be patient for a few minutes. Hello Bhagya, I am back. So I'll place everyone on mute. I'll place everyone on mute because there's a lot of noise. So if anyone want to talk, you can ping me on chat, and I will unmute at the time because there are too many folks and it's really distracting. Okay, I hope you guys can hear me. I put everyone on mute, and now there is not much background noise. Uh, Bhagya, can you confirm that you can hear me at least? Okay, 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 cool. Let me unmute Bhagya. Hey Bhagya, can you hear me? Uh, yeah. So, shall we start or shall we wait for a couple of more minutes? Okay. Yeah, sure. Okay, sure. Yes, yes, Bhagya, I can hear you. Yeah, I hope you guys can hear me. Before I start, I just want to confirm. And also, I hope you guys can see my screen. Hello, can someone confirm that you guys can see my screen? Yeah, so my name is Durga, and today I will give brief introduction on big data ecosystem, Hadoop, Spark, and few other tools within big data. And also, I will try to give all you about several distributions we have in big data. On top of those, I will also try to 1 minute, okay? Okay. I will also try to explain resources that are available. Okay, first I will start with my introduction, then we will get into big data. I will try to talk about the resources that are available online to explore big data technologies in detail as we proceed. So before we start, my name is Durga. Here is my LinkedIn profile. Okay, this is for Bhagya Sri. Ankur is asking, please ping the ID where attendance has to be sent. So Bhagya can send you. So let me proceed. So this is my LinkedIn profile. You can connect with me on LinkedIn. And I just started my own company around a year back in the pursuit of provide high quality training and services in the areas of big data and cloud. As of now, we are primarily focused on big data, and we are entering into cloud. And the differentiator between others and us is we try to provide quality training with respect to certifications, and also we will try to instead of teaching one programming language or one technology, we will try to uh, provide training based upon the framework. Okay, and most part of it, all the content is available for free. So as of now, we are primarily focused on big data and cloud. I am expert in big data, and we are also venturing into cloud. And my company is based out of Dallas, and we are extending our operations to India as well. So that is a brief introduction about me, about my company. And experience-wise, I was a database architect, enterprise architect, a senior manager in companies like Symphony Teleca, IBM, as well as Cognizant. Before I quit my job and start, so there are some things people are asking. Let me see. Okay, I will leave it like this so that I can see the messages. I'm not sure. Harjot or someone is pinging for some information. Probably Bhagyashree can take care of it. Okay, anyway, I hope you guys can see the screen. That is more important, and I will share all the resources with respect to the training. From CSC perspective, if you need any email IDs and all, I am not the right person. You might have to share, discuss with the people who communicated about this session to you. Okay. So with respect to my profile, I was a database architect, enterprise architect, and from technology stack perspective, I worked on many technologies, many programming languages, many tools, starting from enterprise applications to data warehousing and big data. Okay. So let's start with today's agenda. The way it will work is, okay, so people are asking for ID. I'm also not sure, Harjot. What Bhagyashree have mentioned is you got an email from Divya about this meeting. So you just have to send to her. That's what Bhagya has mentioned earlier. You can check with your colleagues about that email ID if you did not get that email ID. Okay, so I will start with the categorization of enterprise applications and typical data integration architecture and what are the challenges with conventional technologies. Out of 2 hours session, probably 40-45 minutes, I will try to explain the legacy architectures so that you know what are the challenges with respect to legacy architectures and technologies, and where big data ecosystem can solve certain problems, or where it might not be the good fit. Unless you know the history of traditional application architectures and traditional technologies and the challenges you will encounter, you will not be able to figure out where big data actually fit the bill. Okay, and then we will see different components in big data, how data is stored in big data, how the data is processing, how the data is actually ingested into it, and how the data is visualized out of big data ecosystem. And then we will actually get into different certifications and distributions as part of this session. So it will not be a lot of Hadoop oriented. It's much higher level. It's about transitioning from legacy technologies to big data technologies, where big data technologies can fit the bill compared to legacy technologies. Okay, so now let me start about me. So this is my website. So let me briefly give overview about several components we have. If you want to learn in future, you can follow these several components which are provided by ITversity to update to learn the skills with respect to big data. So around a couple of years back, I started this channel called ITversity. Okay, and there are almost 1,050 videos on different technologies, but mostly it is around big data. So when I say big data, it's not just about development, but also about how to set up the clusters and many other skills that are relevant for big data are covered as part of these videos. Apart from big data, there are other videos also, but I can say the channel is predominantly big data. So it seems someone is speaking. Let me check. Okay, so the channel is predominantly big data oriented as of now, but eventually, as I mentioned earlier, we will be covering many other things. We will be getting into cloud and many other emerging technologies. So one of the challenge with video content like YouTube is, if you need to check for a particular topic or for a particular piece of code, it is very tough to navigate through the content and get the details of it. So we just launched this website called itversity.com very recently, wherein using the videos in YouTube, I actually created courses. So this will actually give the flow to learn in much more user-friendly fashion. And then when you learn, you obviously get doubts, even though it is free. It's very important for people to get your doubts resolved as quickly as possible, especially when it comes to open source technologies. The documentation is not very good, and leveraging the expertise gained by others, if we can have a platform where it can be the knowledge can be shared between the people, we can accelerate our learning process. So for that purpose, I have started a website called discuss.itversity.com. It's a discuss is subdomain under itversity.com, and here you can actually go ahead and ask any questions related to big data or any other technologies which we will be covering going forward. And finally, we also have a website called labs.itversity.com. So learning big data requires resources. And either you need to have a high-end laptop or a multi-node cluster. Those high-end laptops and multi-node clusters are out of reach for many people. For that purpose, we actually launched a website or a platform where people can sign up for as low as $15 a month or $55 for 6 months, and get access to a multi-node big data cluster and start learning the skills while practicing in the lab. Okay, it's a 7-node cluster. It's pretty powerful, and I will give for you about the cluster towards the latter part of this session. So these are the 4 components: YouTube channel, website, forums website, and the labs constitute our big data learning platform. On top of these things, I also give corporate trainings. People who want to learn self, they can learn for free while practicing in this paid lab. And if you are looking for corporate training, I also take care of those trainings as well. And when it comes to the expertise, I take care of both infrastructure, where we have to set up the cluster, enable security on it, as well as from the development perspective. I have the unique skill set of handling both infrastructure as well as application delivery. I'm both a developer as well as an infrastructure guy. I have the history of managing architecting from both the development perspective as well as infrastructure perspective. I can cover almost all the topics with respect to big data, whether it is infrastructure or development. That being said, let's move on to the other topics. It means if you want to connect with me on any of the social networking platforms, you can go through these links and follow me wherever you are active. Okay, so someone is asking, I don't know why I'm not getting the notes highlighted here immediately. For some people I am getting, for some people I am not getting. Okay, so I think Kavita has some questions. Okay, not this one. Okay, someone is asking about how to join the audio. Let me see. Please come closer to phone. There is a bit of echo in the audio. Okay. Okay, so Subra Suman is saying, could you go to IT Varsity site once? I can unmute you, so you can ask the questions. Subra, what is your name? Subra? Yeah, let me unmute you. Okay, I think you are on phone. Okay, let me go to IT Varsity. So yes, which one? Do you want to go to itvarsity.com or I don't know which what is our caller ID, so I might not be able to unmute. Okay. Okay, yeah, go ahead. What do you want to know on this? So the website is still crude. We are trying to create courses. We are trying to create courses, and eventually all the courses will be available here. Okay. So don't worry about this thing. The presentation will be shared with you, and also this video is streamed to YouTube, so you can actually get this video anytime later. As you will get this presentation, you have all the links over here. So don't worry too much about it. Okay. I hope I have seen questions from everyone. Yes, this presentation will be shared. Okay, so let me move on, and we will take the questions later. Just pause on the questions because I am new to this platform and it's really distracting. Typically, I take questions as I go, but here it is not possible. So let me move on, and I will take the questions to. I will give few minutes wherever we reach certain milestone, and we can take the questions at the time, and then we will proceed further. Okay, so categorization of enterprise applications. So when we think about enterprise applications, traditionally we have two types of applications. One is operational and the other one is decision support. So what is the example of operational? So if you take a retail company like Walmart or Target or any other major retail company, the point of sale system is an operational thing. So you go and you buy the products, and and it has to be finished as quickly as possible. If you go to e-commerce platform, the market basket checkout. So you place the order, and once you check out, the order has to be placed, and that use case is typically operational. And also, when you try to search for a particular product, it actually display the recommended products. So, for example, if you go to Flipkart or Amazon, and if you try to buy a 55-inch color TV, you should get appropriate products which you might be interested in buying. The platform should be smart enough to decide and push those products which you most likely will buy along with the expensive TV, which is called as recommendation engine. And that recommendation engine also kind of operational. Operational means it should be in interactive fashion, and there should not be much of latency. And then decision support. Decision support is typically get the data from transactional databases or multiple sources, and then generate reports out of it. Okay. So, for example, if you take the same major retail store like Walmart or Target, if the executive management want to see which products are selling well and which products are not selling well, or which store is performing well and which store is not performing well. If I want to see the trend of regions, so stores will be typically divided into regions. And if the executive management want to see which region is performing well, those are all decision support, which will help you to identify the problems, troubleshoot those things, and take executive level decisions to improve the bottom line of the company. And those are considered as decision support applications. So typically operational, the user base is pretty huge. Each and every customer who are trying to buy some products from retail store will be user in operational. But when you come to the transaction and the number of amount of data that will be generated in each transaction, it will be minute. You will not even deal with a few kilobytes of data in each transaction. Okay, but when it comes to decision support, you capture huge amounts of data, process those things, and generate report to executive management in the company. So the user base is pretty small, but the data that needs to be processed is quite complex and pretty huge. So typically, when it comes to operational use cases, we use J2EE or some other enterprise application technologies to build. When it comes to decision support, we use BI tools, ETL tools, etc. Right? So these are traditionally two types of applications which we see in an enterprise. But with the success of the social networking platforms, mobile phones, etc., now we see a third category, which is called as customer analytics. Okay, and what is customer analytics, and how is it different from operational or decision support? So, customer analytics, one of the use cases, let's say you are a regular buyer in Flipkart, and at the end of the year, you want to know which categories you are actually buying and which categories you are actually spending money. Okay, so Neetu Vaswani is asking for some help. So let us see what it is all about. We are not able to listen through audio option. So you have to dial in. And you can go to audio video, click on dial in instructions. So if you So Indrajit is saying my voice is not clear. I'm not sure how I can fix this issue because I am also relatively new, and we have. Let me send a note to everyone. I have the backup of this as a YouTube session. You can probably follow that. later. Okay, so most likely it should be fine. You can actually access that link later, and the entire video is streamed to YouTube, and you can watch it. Okay, so let me proceed. So what I'm talking about is customer analytics. So these days, giving information to users about how he's spending his money is will improve the customer experience. So a lot of companies are working towards customer analytics. Companies like Amazon, Facebook, YouTube, even traditional enterprises, they are primarily focused on customer analytics. Now let us understand the technical challenges. Okay, when it comes to customer analytics. So customer analytics is kind of decision support, but the user base is pretty huge. Each and every customer want to see certain reports, but the reports need not be very complicated like in decision support. But the reports might be, the user base might be very huge, and we have to address that problem. And for decision support, we traditionally use enterprise BI tools such as Cosmos, Business Objects, etc. For reporting purpose. And for storing the data and all, we traditionally use Teradata, Greenplum, Vertica kind of technologies. But with customer analytics, none of these technologies is very reliable. Hence, we have to explore new suite of technologies, and big data plays a crucial role in that customer analytics. On top of customer analytics, big data is also making some capturing some market in operational as well as decision support use cases. We will get into those details as we proceed. Okay, so now let me move on to the next slide. Hello. Okay, so most of the traditional applications are considered monolith, which means we follow entire architecture. Yeah, so please go on to mute. If you guys are listening on YouTube, please go on to mute. And Vijay is saying that voice is much clearer in YouTube. Okay. I'm hearing a little bit of echo. Whoever is not speaking, please click on mute on your phone. So most of the traditional applications are considered monolith. Monoliths are typically built on RDBMS databases such as Oracle. Typically, entire applications, take any bank application or POS applications for retail, these are all typically considered as monolith. Modern applications use microservices and considered to be polyglot. So let me give an example of modern application. You can take LinkedIn itself as an example. And if you actually look at LinkedIn, okay, and here your LinkedIn website is just a gateway to multiple microservices. You have a microservice where it is actually recommending who is viewing your profile. And if you go through LinkedIn website, you see different types of content. Means if you go to your profile is one type of content, and if you scroll down in your profile itself, you have recommendations, you have endorsements, you have many other things. So this is endorsements. So you have many other things where skills are placed and endorsed. And on top of it, you can go to jobs section and you see the recommended jobs for you based upon your history. So there are several modules which are being developed, and these modules are developed as microservices and leveraging the relevant technology for the kind of microservice it is using. For example, if you go to profile and if you go to endorsements, probably a NoSQL database might be ideal candidate for that microservice to store the data rather than storing in relational database. So this is a very, very important point. Modern applications use microservices and considered to be polyglot. Take the example of Facebook, LinkedIn, Netflix. most of the modern technology companies typically develop their applications in the form of microservices. And if you are an application developer, you should understand this term called polyglot, wherein each microservice use its own set of technologies which are relevant for that microservice. And one of the very important aspect of this, that too in the context of big data, is the database. So you should know which microservice should use what type of database, and we will get to that in a later point in time, where we'll explore different database technologies that are available, and we should have an idea about which database technology you should use for what type of application. I will give few examples at the relevant time, but make sure you understand that most of the traditional applications are considered monolith, and modern applications use microservices and considered to be polyglot. Now we have choice of different types of databases. We will see later. Okay, take the example of Flipkart or e-commerce. You can think about operational use cases. Operational use cases can be transactional and not transactional. Example for transactional is checkout. So if you go and if you try to buy a set of items by placing an order, so something has to be debited from your account. Some money has to be debited from your account and credited to the e-commerce platform, and the products has to be placed as an order. So and when the products are placed as an order, wherever your products are stored in the database, the product, the quantity of that product has to be reduced. All these things has to be committed as one unit or rolled back as one unit if something goes wrong. So these examples of checking out while buying products is considered as transactional. Yes, someone is actually speaking. Please go on to mute. Whoever is not speaking, please go on to mute. Okay, so let me do one more thing. Let me just go to participants and mute all so that everyone is muted. Okay, and when it comes to operational, the recommendation engine, if you go to Amazon or Flipkart, when you try to buy something, you have to get the recommended products based on different affinities, and that is not transactional, but you have to get the information as quickly as possible. So it is considered as operational but not transactional. Okay, and then decision support. The sales trends which I have explained is kind of decision support. Customer analytics, categories in which customers have spent money. So these are the examples which you need to understand what is operational, what is decision support, and what is customer analytics. And now you should be able to determine which database should be used for transactional use cases, which databases should be used for not so transactional but operational use cases, which technologies should be used for decision support, and which technologies should be used for customer analytics. Okay, it's very important to start analyzing from a very high level, and then drill down and choose your technology stack based upon the use case. Data from and one more thing is, for both decision support and customer analytics, data from transactional systems need to be integrated. Okay, only then we'll be able to derive something out of that to either support the decisions of executive management or to perform the customer analytics. Without sourcing data from transactional systems, you will not be able to derive decisions out of that data and also run customer analytics on top of that data. So integrating this data from transaction systems is very, very important. And that comes under data ingestion. Data integration can be categorized into two: real-time and batch. So batch means you will get data once in a week or once in a day, again in batch there are micro batches or macro batches. Micro batches are typically, if you try to get data within every 8 hours or less, those are called as micro batches. Typically most of the batch runs happens daily basis. Real time, sometimes we have to get the data in real time from source systems or source databases or web logs, whatever it is, so that we can run analytics out of it. One of the examples for integrating data in real time is, again, if you go to LinkedIn and if I endorse someone, that endorse has to be reflected immediately on his profile as quickly as possible. Okay, so if you scroll down to endorsements, if someone endorses me, it should be displayed as quickly as possible. So it's kind of real-time analytics. So we have to get data in real time, run some analytics out of it, and store the aggregated data and start generating the reports. Okay, so that is an example for integrating data in real time. Traditionally, when there are no customer analytics and recommendation engines, we used to have ODS, compliance and single source of truth. ODS stands for operational data store, and EDW. So traditionally, we used to get decision support through EDW, and to get the data into EDW, we used to develop the data integration frameworks to load data into ODS and then EDW. We will see the example later. And the term which we used to use to get data from our transaction-based databases into these decision support systems is called as ETL, especially to perform transformations and load data so that we can report out of it as quickly as possible. And BI is used to visualize and publish reports. So when it comes to the data integration with respect to current architecture, so there is some issue with me too. Okay. Okay. So traditionally, we get data from these source systems into downstream system, which is called as EDW typically, and we use ODS for different purposes like compliance and also to troubleshoot our reports. And to get data into this ODS and target system, we typically use ETL or real-time data integration tools such as Golden Gate, SharePlex, etc. And from source, data goes through the data integration layer. For batch, we use technologies like Informatica, DataStage, MicroStrategy. So MicroStrategy is reporting tool, Ab initio, and those kind of technologies which we used to use for batch ETL. And for real time, we used to use SharePlex or Golden Gate. And then data is either copied to ODS and then perform ETL and load into EW. Sometimes we directly get the data from source and get data to target system directly. Okay, and then once the data is processed, we typically connect our reporting tools to ODS or EDW and generate reports out of it. So these are the technologies which we typically use. For batch ETL, we use Informatica, DataStage, etc. Real-time data integration, we use Golden Gate, SharePlex. For ODS, so if you go to this is nothing but a database, and for ODS we typically use Oracle or MySQL or some other traditional RDBMS, and for EDW we use Teradata, Greenplum, etc. And these are the technologies we use for BI tools. And when it comes to challenges with these technologies, almost all operational systems are using relational databases. Okay. And if you think about it, RDBMS are originally designed for operational and transactional. When I say operational and transactional, that means, again, if we take the point of sale system to check out from a retail store, you have to debit money from someone's credit card and credit into the company's account. And then products have to be reduced from their store database, and then this guy has to complete the transaction and come out of it. So that is considered as both operational and transactional. When we say transactional, it means that we do insert operations, update operations, and delete operations to adjust the data within the databases. Typically, it can be 10 or 15 operations depending upon the complexity of the transaction. And every operation, they have to so each and every operation within those 50 operations has to be either committed or rolled back as one unit. If it doesn't happen, then you will start getting inconsistent results, which means you will have challenges in the actual transactions itself. So RDBMS are originally designed to address the issues such as running into inconsistencies because of the partial transactions, etc. And if you are familiar about a person called Boy Scott, he is the one who actually wrote a white paper about normalization and other RDBMS related stuff. And using those principles, most of the RDBMSs are developed. Examples are Oracle, SQL Server, Informix, MySQL, all these things. So again, I am getting background noise. Let me mute everyone. Okay. So can everyone go on to mute? I am hearing background noise. It's Ramkrishna Reddy. Can you go on to mute? Okay. Now it is better. So all these RDBMSs works very well for transactional based systems, but though they so whenever the transactions happen, there is a lot of overhead that needs to go through to make sure that each and every operation within while doing the checkout are committed or rolled back as one unit. Okay, due to which databases are not linearly scalable. Okay, and the overhead is for transactions and also data integrity. So if you think about it, when you create the tables in RDBMS, you specify the column names, data types, primary key constraints, foreign key constraints, and all these things needs to be validated. Which means that whenever an operations happen in the database, this overhead will actually become an issue while dealing with huge amounts of data. And the proper term is these transactions and data integrity checks will actually make the RDBMSs not linearly scalable. And they're expensive. All RDBMS technologies, whichever is not open source, are very expensive, and they're predefined. They have predefined schema. And one more thing is data processing do not happen where data is stored. This slide is very, very important. This actually highlights why we need a new ecosystem of tools to address certain use cases which scalability is important. Okay, and big data is all about processing the data, or supporting the operational use cases where scalability is highly relevant. Okay, I will give several examples as we proceed. So here, one more thing you need to understand is in traditional databases, data processing do not happen where data is stored, which means that there is no data locality. So let me see if I have the slide. I don't have slide here. Let me show you a slide. I think it's in a different presentation. I will try to figure it out real quick if I have one. Yeah. So if you think about Oracle architecture, okay, you will have a storage layer. Storage layer in the sense you will have a storage rack in which you put or you install a lot of hard disks in it, and then you carve out the necessary amount of storage, which is nothing but a logical volume, via network switch onto set of servers. So this represents database server. This is storage server. So what is database server? It is nothing but a little bit of storage to have binaries of the software which is being installed, and then you have CPU and memory, so that the customer requests are supported to execute SQL by executing SQL, like insert, update, select, etc. So you have the database servers, which are nothing but CPU and memory here, and you have the storage here. and these two things are actually connected to through network switch. Okay, and there will be another network switch, and it is used to for the intercommunication between the database servers. So why this slide is important is, if you think about processing the data, okay, so you have 10 GB table, which is or you have a table where there is 10 GB of data. The 10 GB of data will be permanently stored in this layer. Let's assume that there is no indexes, and you want to get the count of number of records of the 10 GB table. So you will issue a query on the database server, such as select count of stars from the table name, and that query has to be compiled where it can actually do the network I/O, and this entire 10 GB data has to go to this network switch into the database server, where only the I/O happens. So here the point is, data which is remote to the storage layer, which is on storage layer, which is remote to the database servers, has to travel through network switch into the memory of the database server where the actual data is processed, and you will get the results. So here, while running a simple query, such as select count of star from a table name, you have to get 10 GB worth of data via network switch into the database server to process. Where so if you think about larger size tables, this can be significant overhead, and we have to eliminate that to get better scalability. So now if I go back to my previous slide, so I'm dialing in. Just give me a moment. I'm dialing in. Let me make a note here. Hello, I'm back. So can you guys hear me? So I'm back. I hope you guys can hear me. And hello, can you hear me? Hello. Okay, thank you. So I hope you didn't miss anything. Okay, stop. I'm back. Okay, so I understood now. So let us go back to the slide. I hope every guys, every one of you actually seen the earlier slide where I have covered about Oracle. One minute. I will send it to the coordinators. Just give me a moment. Okay. So I hope you guys have seen the screen and the PPT about Oracle. What is happening? For some reason, it is not coming up. Anyway, let's go ahead. I hope you have seen that. Okay, now let me move this aside. So I'm talking about the challenges. Okay, so some processing happens at database server level, where the SQL is submitted and compiled. Yes, Indrajit, you will get this. You will get the PPT. I already shared with your with the coordinator, and every one of you should get the PPT. Or you can actually send the email to my email ID training@itversity.com. So let me give my email ID in case if you do not get it, I can send it to you. Okay, I'm sending note to everyone here. training@itversity.com. Okay. So now let me take you to the presentation. So the main point here is the processing happens everywhere else other than the storage layer. Okay. Yeah, some processing will happen at SQL as part of database where the SQL will be compiled and it will fetch the data and do the processing. Some processing might happen at application server layer. Some processing might happen at client or browser layer, but no processing happens at the storage layer. Almost all data warehouse appliances are expensive, and this is another challenge. So some of these problems, which I have been explaining as part of this slide, are already addressed with technologies like Teradata, Greenplum, Vertica, but they are expensive. And even though they can address these problems, they are not very flexible for customer analytics and use cases such as recommendation engines. That's where we need to explore the big data technologies. Now, when it comes to databases, most of you might be from application development perspective. From application development perspective, you should visualize. You should understand the types of databases and see which database will serve your purpose. Okay. So now we started with relational databases. Earlier, all the applications used to be developed on the relational databases. And then when analytics or enterprise level reporting started gaining momentum, we started implementing data warehouse technologies such as Teradata, Greenplum, etc. Now with Google, Facebook, Amazon, all these companies, they neither use RDBMS nor use technologies like data warehouse or MPP appliances for their recommendation engines, endorsement engines, blogs. I mean, there are many examples, and for all those things, people typically use NoSQL databases. Cassandra, HBase, MongoDB fall in that category. And then in-memory databases, so where the data will not change significantly, but accessed very frequently, you can actually store the data in in-memory databases. Gemfire and Coherence are the technologies, and Gemfire is the one which actually improvised IRCTC performance. So earlier IRCTC used to go down very frequently, completely unreliable, because each and every request used to hit the database. And if you really understand the application lifecycle, the most expensive operation in a well-written application is the database operation. Earlier, all queries used to do a database operation in IRCTC because the user base is so huge. it used to get into so many issues. Now, use cases such as searching for the trains and all those things are moved out of database, and they are supported by in-memory data grids. They have actually implemented Pivotal's Gemfire or EMC. EMC is the one who owns Gemfire now. And then search-based databases. So if you want to implement search engines as part of your application, there are Lucene-based technologies such as Elasticsearch, Solr, etc. So you can explore those technologies. And then for batch processing framework, we now have MapReduce and Spark, where the processing happens in distributed fashion. And for graph databases, we have Neo4j. So from an application developer perspective, you should have an idea about all these databases so that you decide which database needs to be used for your use case. It's a very, very important slide to understand all the different types of databases. I'm not talking about different databases, but I'm emphasizing on different types of databases. First, you need to choose the type, and then you have to explore the feasible database technology out of that type. And modern applications needs to polyglot, which means that different modules need different category of databases. Again, if you go back to LinkedIn, LinkedIn takes the payments from companies where they want to post the jobs for the where the companies want to post the jobs to hire the talent. So for that, LinkedIn actually charges so much amount. Okay, so those things have to go through relational database so that you get the backup recovery features of relational database, and you will not lose any transactions. And if some executive management want to see a report about how the revenue is being generated within LinkedIn company, they might have to use data warehouse or MPP appliance. I heard that LinkedIn uses Teradata, if I'm not wrong. And then for recommendation engines, endorsement engines, all those things, they serve the user requests from using NoSQL databases. But in the backend, to provide the data for recommendations and endorsements, the data is actually processed using distributed technologies such as MapReduce and Spark, because they have to process gigabytes to terabytes of data on a regular basis. And then for caching and all, they use in-memory data grids. And for search-based, LinkedIn might be using some Lucene-based such technology. Okay, so I am only talking from databases perspective. When we say polyglot, it's not only database. Any means the entire technology stack might be different for that microservice. One microservice might be developed using MeanStack, and the microservice might be developed using Django, and the microservice might be implemented using Ruby on Rails. It could be any technology. Each microservice might be using different stack of technologies, but I am primarily focusing on databases because big data is more relevant from database context, more relevant in database context. Now we are getting to big data ecosystem. How it will actually, we will see brief history about it and what are the different components that are available as part of big data ecosystem to address the challenges which we have covered as part of this and provide scalable solutions. Okay, we are getting into big data now. So history, it started with Google search engine. Big data as a concept actually gained momentum with Google search engine. Google sees different from enterprises of that time. Okay, so they are not actually trying to build a checkout application or a transactional-based application. What they are trying to do, they are actually crawling web pages, index based on keywords, and return search results. They started with MySQL database, but soon they realized that it will not serve their purpose. So, as they decided that conventional database technology does not scale, they implemented 3 technologies. Okay, one is GFS, which is Google File System. Second one is Google MapReduce, which is distributed processing engine, and third one is Google Bigtable, which is distributed index table. So how they work? So Google crawl the web pages, they create archive of those and dump into this distributed file system where larger files will be distributed across multiple nodes in the cluster. And then MapReduce is developed in tandem with GFS. So MapReduce understand where the data is stored. So instead of getting data to code, MapReduce will actually go to will make sure that code goes to the data and processing happens much faster in distributed fashion. Okay, we will see how it works a little bit later. And then Google Bigtable, once the data is processed, it needs to be indexed so that when you try to search, it actually gets the relevant results for you. And these results will be stored in an indexed table, which is called as Google Bigtable. So these three technologies actually provided much more reliable and sophisticated platform for Google to provide results as quickly as possible. So I will cover a few myths about big data. A lot of people think that big data is Hadoop. It is not the case. Hadoop is just one component of big data, but it is one of the major players within big data. Big data ecosystem can only solve problems with very large data sets. It's another myth. Nowadays, people are actually trying to use big data for even in use cases where a few tens of gigabytes of data is being processed or served. And another big myth is big data. They think that big data is cheap, but it is not cheap. Even though there is no licensing and several other things not involved as part of big data, still learning curve is so steep. And also one more thing which you need to keep in mind is if you follow the industry in the past 10 years, almost all the big enterprises actually invested millions of dollars in building new data centers for high-end hardware, where you install IBM P-series computers or Solaris Superdomes, where you will get computers with servers which will have 128 GB, 256 GB RAM, and few terabytes of storage, which is typically network mounted, where RAID is configured and all those things. For those kind of systems, they have actually started building new data centers and started hosting these servers in that, and then they slowly migrated their applications into these. And most of the big data success stories are on commodity hardware. Take the example of Google, Facebook, or any other company where they use big data quite extensively. The success stories are primarily on commodity hardware. And now if you think if these big companies have to set up commodity hardware in their data centers, and the environment might not be good enough. So even though hardware is cheap, software is free, still it might be expensive for the companies due to several reasons. One is the data center might not be able to support this hardware, or it might be this hardware might not fit into the existing ecosystem of many enterprises. And second scenario is learning curve is very steep. For those two reasons, big data is not cheap. And then the fourth myth is big data provide variety of tools and can solve problems quickly. Big data is just a concept. There are several tools which will try to address the big data problem, but there are no out-of-the-box tool which can solve the problems very quickly. A lot of guys think that big data is a technology. Big data is not a technology. It's like RDBMS is a technology. RDBMS, which is incorrect. RDBMS is not a technology. It's just a concept. But RDBMS is the outcome of a PhD, and it is very well documented and much more complex compared to big data. Big data as a concept might not be as sophisticated as relational databases. There are only three characteristics with respect to big data: volume, variety, and velocity. And a lot of guys are adding new terms. But the main point is big data is not a technology. It's just kind of a concept. And a lot of guys think that big data is data science, which is another big myth. Data scientists need to have specialized mathematical skills. You need to have domain knowledge, minimal technology orientation, and data science itself is a separate domain. If required, big data technologies can be used. If not required, there are scenarios where data scientists actually do the research just by using Excel. Okay, if the data set is not so huge, you can use other technologies also. Okay, so data science is a separate domain, but in some cases where it running the data science algorithms involve very huge data sets, then the IT team has to support the data science team to provide the framework where the data is fetched from the different sources, cleaned and processed, so that data science team can actually use the data and generate some and perform R&D based upon that data. Okay. And often people have unrealistic expectations on big data technologies. So a lot of companies, when especially services organizations, when they propose big data, when client asks questions, instead of understanding the complexity of the problem, they will just compare with the current state scenario and try to give numbers. So, for example, if they are implementing a new report in traditional technologies within 3 weeks, and if the executive management asks from the client side, if the executive management asks how much time it will take to roll the same use case in big data ecosystem, at times people tend to promise that it will be done in 4 weeks or 6 weeks without digging and understanding the real complexities involving big data, and that actually create a lot of problem. So you have to first research and see that problem can be solved in big data or not, and then you have to add the overhead, learning curve, and all those things, and the numbers. You have to set right expectations to the client. Okay. So when it comes to big data ecosystem characteristics, I'm talking about technology characteristics. Okay. Typically, big data is stored in distributed fashion. Fault tolerance is primarily done using a concept called replication. I will explain you. I will just I will try to run some hands-on exercises, hands-on demonstrations, and I will explain a little bit in detail about this. Okay, distributed storage is the main point, and fault tolerance. For fault tolerance, we typically use replication in most of the big data technologies. And then distributed computing or processing. When it comes to data locality, code goes to data. Scalability, it's almost linear. Nothing is always linear and completely linear. There will be some overhead, but it is almost linear. You can get the best of the scalability using big data ecosystem. Low cost hardware and licensing costs are very cheap. Most of the software is open source, but that doesn't mean that big data is cheap for enterprises for the reasons which I have explained earlier. So big data ecosystem of tools can be categorized into distributed file systems, distributed processing engines, and distributed databases. So distributed file systems are HDFS, which is nothing but Hadoop distributed file system. Cloud storage, which is nothing but S3 from Amazon or Azure from Microsoft, Azure Blob from Microsoft. Distributed processing engines, we have MapReduce and Spark. Distributed databases, we have NoSQL databases such as HBase, Cassandra, such databases such as Elasticsearch. So if you want to implement certain things which are in operational nature, you can consider distributed databases as long as transactions are not highly relevant. Okay, after successfully building search engine in new technologies, Google have published white papers. GFS for distributed file system, MapReduce for distributed processing engine, Bigtable for distributed database, and development of big data technologies such as Hadoop is started with these white papers. So data storage options in big data ecosystems. Let us see what are different options we have. Typically, we have either HDFS or cloud storage. HDFS is distributed file system. And then distributed databases for random access distributed indexed tables. So distributed databases is primarily for random access in real time. We want to get the results as quickly as possible. For that, we typically want to use distributed and indexed tables, which is nothing but Cassandra, HBase, MongoDB, Solr, etc. Okay, so these are several options when it comes to storing the data. Okay, so before getting into data ingestion, let me do a demonstration. Okay, here I am logged into the lab. So once you sign up to the website and make the payment, and then you will get credentials to the lab. If you are new, you will not see this page. It will take you to the plans page, and then you have to click on enroll now on the appropriate plan. And once you choose the appropriate plan and click on enroll new, it will take you to PayPal gateway, and then you will get the credentials to the lab. Now either you can use terminal such as this. Okay, you can actually click on this open console, which will open the terminal itself, but in the web page. This is only for convenience purposes to get started. Typically, you should use terminal like this or PuTTY. If you are a Windows guy and if you are familiar with PuTTY, you can use PuTTY or Cygwin. Okay, so let me click on this again. And once you click on the open console, you will get the username and password here. This is username and this is password. For some reason, it is not coming up. So let me ping this URL. Okay, let me explain you. Let me explain you once again. Okay, I think you did not join earlier. So this is the website. You will not be able to access this now. Okay, you need to make the payment if you want to access the lab. Don't think that it is marketing material. I just want to demonstrate a few things so that you understand what is distributed file system very briefly. Okay, so this one will actually give the credentials to the lab once you enroll by making the payment. So you can click on this open console. Now you see here, this is the host IP address or host name, and then you can copy this username. If you are using Windows, try to use Chrome or Safari. For Chrome or Firefox, and use Shift Insert to paste into this. Okay, don't use Control V; it will not work. This is password, and hit enter. Now it will take you to the lab. Okay, so this is the gateway node, which is remote to my PC, which is hosted on a hosting site. And here, if I run Hadoop FS, I can interact with HDFS file system. There are several commands. If you type Hadoop FS and hit enter, you will see all different commands. Okay, and you need to go through these, and you need to understand. Typically, to copy files from local file system into HDFS, we use this copy to local command. Okay, and it will look like this: Hadoop FS, copy from local, and then we have to give local path of the files which we want to copy into HDFS. From this machine gateway node, I want to copy files into HDFS. I will explain what is HDFS and all those things in a moment. But to copy into that distributed file system, you have to use this command called copy from local, and then you have to give local path, which typically start with /home Raju. So in this case, I want to copy something from here, and let me say word count.txt. And then I have to copy to HDFS path. HDFS path typically starts with /user, and there will be a directory to which you should have access to, and then you can copy files to that location. Okay, once you copy files to that into HDFS, now I'm not running this command because I already have files, and I will show you how they look like. Okay, so it seems there is some quotient. So let me take this. Okay. It is Linux OS. Okay. It is Linux OS, Linux OS, and let me show you how the cluster look like. So once you log in, once you get access, okay. I think this AT&T Connect is at least 10 years behind. WebEx and GoToMeeting, all these are much better. There are so many features missing even today in this tool. Anyway, so here you can see Ambari URL. Okay, if you click on that, it will also ask for username and password, and you can actually use the same credentials. This is the username and this is the password. Okay, copy password and paste it here. Sign in. And this is the cluster I have. So these are all called as services. Okay, services are nothing but software which is deployed on a set of hardware. What is the hardware? Click on the hosts and it will show the hardware. So there are 7 machines supporting this cluster. One is GW01, other one is NN01, NN02, RM01, and WN01, WN02, and WN03. So this is just naming convention to tell what is slave, what is master. So this is gateway node, and these 3 are masters. Don't worry too much about these things now. Our actual data will be stored in these 3 nodes, which are categorized as worker nodes. Okay, and if you look at the configuration of each node, each one have 8 cores and 32 GB RAM and several terabytes of storage. Okay, and so when I run Hadoop FS copy from local, I'm running on gw01.itverse.com and give the HDFS location. The files actually be stored in distributed fashion in these machines, WN01, WN02, WN03. So there is something called name node web interface. Okay, name node is master to deal with your HDFS. So now again, if I go back here and click on services, go to HDFS, we will see the architecture of the HDFS service. So there is a name node, there is secondary name node, there is data node. So name node and secondary name node are masters for HDFS. To understand how your data is stored, you have to go to the master. Only name node can give the information. So in this, if you have access, you can go to quick links and you can see name node UI. Okay, and if you go to the name node UI, you can actually see the details about the files that are stored. You can click on the browse the file system under utilities, and I will take you to the path where everyone have access to. You can also actually get to this link. Probably there are too many people. It might become slow, but still I can. You can give a try. Okay. Notes. You can click on this URL. Okay, but don't try to download or anything from here. Just watch. So if you these files I have given access to everyone, so only in these directories anyone can go and see. And if you click on cards, there is a file called large deck, and the size of this file is 693 MB. And here you need to understand 2 parameters or 2 properties of each of these files: 128 MB for block size and replication factor as 3. Okay, and this is very important information. And if we go back to if we go back a little bit in the slide, I mentioned that as part of the characteristics. Fault tolerance, RAID is replaced by replication. I'm not sure whether you guys are familiar with RAID or not. It's primarily to make sure that your application is up and running even if some of the hard disks fail. Okay, so if you do RAID 1.0, even if half of the hard disks fail, your application will be still up and running all the time. It will not even get a second of outage. It will be transparently supporting your application without even without the end users realize that there is something going wrong in the at the storage layer. RAID is very powerful concept, and that is replaced with this replication factor. It's primarily for the fault tolerance in case of server failure or whatever it is. So probably, so Priya is saying that not able to open this link. Probably might be in VPN or your corporate firewall might be blocking, because if you look at the link, it is primarily HTTP, not HTTPS. That could be the reason. So you can give a try at home. Okay. So now if I click on this file, you see here there are 6 blocks, and each block is given a logical ID 0, 1 or index 0, 1, 2, 3, 4, 5. So these 6 blocks will store this 693 MB of data. And how it got 6 blocks? If you divide 693 MB with 128 MB, it gives 5.4. So it is seal of this value. Okay, so it's nothing but size of the file divided by block size and seal of it. Okay, which is upper bound of it. So hence, there will be 6 blocks associated with it. Block size is not fixed. You can override at any point in time while saving the file. But once a file is saved with a block size, you cannot change it. You just have to copy it with new block size. Okay. So at a cluster level, we can set to whatever default we want. But while loading the file, we can override. It is per file basis. It's not at the cluster level. Okay. So here, if you again review these things, you can see the size of the block 0 is 128 MB, which is nothing but block size, and up to the except the last one, every block is nothing but 128 MB, but the last one is the leftover, which is 55 MB. So what is happening? This 693 MB file have actually divided into 6 blocks and distributed on multiple nodes in the cluster, and physically stored. It's the physical storage. So block is nothing but physical storage on those servers, and it actually distribute. So these blocks will be distributed on the cluster. For example, if you see block 0 is actually stored on WN03, WN02, and WN01 because of the replication factor 3. Primary copy is on WN03 and secondary copies are here. Similarly, if you go to block 1, block 1 is actually stored on the WN02. So block is the main concept which make HDFS distributed. Okay. So these files will be stored physically. So these blocks will be stored physically as files on these worker nodes. If you have access as an admin, you can see files with this name. So let me do that. Here I am logging into the cluster as root. Okay, now I am logging into one of the node, which is WN02. And the information, you can get the information about the location by clicking on the configurations after choosing the service using the Ambari. And here you can say data directory or something. Data node, yeah. This is the one. If you see here, so this is the location where the files will be stored physically. So now if I say, let me copy this ID, block ID, Now find slash. I hope you guys are familiar with find command. It is Linux command to figure out the files in the local in the file system. Okay, and here HTTP star. Sorry, find HTTP star hyphen name and hit enter. You see, and let me get the properties of these files. Exarch ls-ltr. So you see this file is 128 MB. You can see it here. So block is nothing but a physical storage, and this one actually will have the data. And your file name. What is the file name? File name is largedeck.txt. It is just logical. If you go to any of these nodes in the cluster and try to search for this largedeck.txt, you will not find anywhere. It's just logical. And the actual storage happens because of the block size. In the form of blocks, the file will be divided into blocks and will be distributed on multiple nodes in the cluster. I have only 3 data nodes, hence you are seeing all the 3 copies on all the nodes. If you have 100 nodes in the cluster, so this file will be distributed on several nodes in the cluster. Okay, so block is the main concept which will drive the physical storage of your file in distributed fashion. Irrespective of the size of the file, it will be divided into multiple blocks and it will be stored. So very good question from Priya. Are data nodes servers? Server is little bit misleading. In the server, think about it as a component of service. HDFS is service. Okay, and data nodes are software servers or software processes. Okay, it's nothing but software. There is nothing physical. Physical servers are W101, W102, and W103. And you can actually get the information by running ps-ef 5 grep -9 data node. It is nothing but a JVM, which is nothing but software process, which will be up and running all the time, which will make sure of storing the blocks physically in the cluster. Okay, so there are 3 data nodes now, which will be actively communicating with name nodes and store the data. Don't worry too much about those things now. Let's don't get into too many technical details. But just understand that HDFS is a distributed file system, and data nodes are the ones which will drive to divide the file into blocks and store physically on multiple nodes in the cluster, on several nodes in the cluster. So the file will be distributed into blocks and preserved in the cluster. If you are interested, you can actually go through my YouTube or website, and there are so much of content that you can explore further. Okay, so let's move on now. So we have several options like this. I have only covered HDFS. Even the cloud storage, such as S3, Blob, also exhibit similar characteristics to store the data. Even Cassandra, HBase, MongoDB, etc., one way or the other do the same thing. But Cassandra, HBase, MongoDB, Solr are primarily used to support real-time applications, and Spark and MapReduce are for processing the data. Now let us understand data ingestion strategies or data ingestion. Data ingestion strategies are defined by sources from which data is pulled and sinks where data is stored. So what is source? The source is nothing but some technology from which data has to be read. And target or sink is nothing but some technology where data has to be written. So depending upon the source and sink, your technology has to be determined. There is no one solution fit which can fit all the problems. So here sources are typically relational databases. It could be non-relational databases also. We have to get streaming web logs, and also there are flat files. So we have to get data from different types of sources. So Mohammed is asking, can we use Hadoop on local app server like WebLogic? Answer is no. I don't want to get into too many details. Don't mix up web technologies with big data technologies. Hadoop is primarily a backend distributed processing engine. There is no web server or application server concept with respect to Hadoop or Spark or you will be using some web servers, so web applications which will be spawned at the time in the JVMs, but don't mix up these WebLogic WebSphere with big data. They are two different uh, uh, types of technologies. Anyway, so let's go back to the data ingestion. We have different types of sources: relational databases, non-relational databases, streaming web logs, and flat files. And sinks are typically HDFS, relational or non-relational databases, and sometimes we might have to integrate data into data processing framework. Okay, so Scoop is used to get data from relational database. So there is a technology within big data ecosystem or Hadoop ecosystem, which is called as Scoop, which will connect to the source database using JDBC, get the data, and store it to HDFS or HBase or some other Hadoop-based technology. So let's understand a few things about weblogs. If you think about Amazon, right, and let's say you want to build a recommendation engine where user go and search for, on a product, and the application should be smart enough to recommend more relevant products with that, which might be bought by users or customers along with the product. Like take the example of 55-inch Samsung LED TV. If you are trying to go with 55-inch Samsung LED TV, most likely will try to buy premium sound system or premium gaming console or premium furniture, right? So your application should be smart enough to recommend these products. Okay, and also if you think about it, not all visitors to the website are potential buyers. Some people add few products into the basket and then they might discard the basket without buying. If we are able to capture the behavior of these users who are visiting the website but are not buying, we can analyze the data, and along we can identify a pattern, and we can give additional discount to make sure that these visitors are turned out into potential buyers. Okay, for all these things, you need to capture data from transactional-based systems and also the visitor traffic. If you start putting or storing all your visitor traffic in relational database, your relational database will explode very quickly. It will be unreliable. For that reason, for all practical purposes, we don't store the visitor traffic in traditional RDBMSs. Instead, what modern applications do is we log into web server logs, and from there we can use technologies like Flume or Kafka or both to read these web logs and then do some analysis out of it. So it is very important to understand the type of source and sink so that you can determine the technology. So in this case, if we have to get the data from relational database, we use Scoop. If we have to get the data from weblogs, we use Flume or Kafka or both. And then Spark streaming, Storm, Flink, etc. are used to process data from Flume or Kafka before loading data into sinks. It is called as streaming analytics. If you want to do streaming analytics, we have to use something called Spark streaming, Storm, Flink, etc. And don't get overwhelmed with all these technologies. These are all highly generic technologies which will solve one particular problem. Okay, if you understand the flow properly, you will be able to use these technologies very effectively with the least amount of effort. But if you get overwhelmed, you will be lost, and it will be very tough to use or leverage these applications and leverage these technologies and build applications for your projects. So batch data processing. So now I have covered ingestion, and data storage. Now we are getting into processing. Once the data is ingested, we have to process the data. So there are two types of processing engines. One is IO based. MapReduce is the main technology for IO based data processing. So the advantage of IO based is you can actually, or MapReduce is you can actually process petabytes of data without running into failures in timely fashion. So you can, in a very large cluster, you can even process petabytes of data within a day or two, which is not possible in any other conventional technology. Okay, well, and then there are few wrappers using MapReduce, because MapReduce is quite complex to use and start building applications. So they provide wrappers in the form of Hive, which is nothing but SQL, Pig, which is nothing but data flow language, which is similar to Python, Perl, etc. Okay, and they are on top of MapReduce. And then in memory, we have Spark, and Spark data frames is wrapper on top of Core Spark. So Spark is typically, all the Spark applications are typically developed using Scala or Python. There are APIs for Java also, but people do not prefer Java because with Java it is a little bit more complicated. I will try to show a use case where we can use Scala and try to develop little bit complex scenario very quickly. If it is Java, it will take significant amount of time. So as part of data processing, typically we focus on transformations such as aggregations, joins, sorting, ranking, etc. Okay, so this is for batch. Okay, for batch there are only two frameworks: MapReduce and in memory, or IO based and in memory. For IO based, we use MapReduce or wrappers on top of MapReduce. For in memory, we use Spark or wrappers on top of Spark, which is data frames. And these are the typical transformations we perform on the in batch use cases. When it comes to operational, data is typically stored in distributed databases. It supports CRUD operations. CRUD stands for create, read, update, and delete. Data is typically distributed, and it is sorted by key, so that when we search by key, we can get the results faster. Fast and scalable random reads, and NoSQL technologies such as HBase, Cassandra, MongoDB fall in this category. And also such databases such as Elasticsearch. And when it comes to analysis or visualization, big data ecosystem does not have many technologies. It's primarily to analyze and visualize the processed data. There are BI tools, custom visualization frameworks, ad hoc query tools. You can use any of these things. Now let us recollect how data integration is typically done in enterprises. So there is some question here. Let me pick this up. Okay, let me go back to the previous slide. Is this the one you were talking about? Okay. So what is your question here? I am disconnected. I'm logging back. So I'm back. Okay, she's saying please move ahead now. So let me move on. Okay. Okay, can please elaborate IO versus in-memory data processing with an example of other use case? So in most of the scenarios, you can choose either of them. Okay, but so Spark is actually capturing a lot of MapReduce market. So earlier, most of the distributed processing use cases are implemented using MapReduce based technologies. But now Spark is capturing that market. There are few slides where I will be talking more about that. So hold on till that point, and then we will see. Okay. So let us move on. I will come back to that point, Ganesh. Okay, so let us recollect. So we have different sources, and as part of the downstream applications, we typically have ODS and EDW, and we have data integration layer, and the data is flowed from source systems through data integration layer to ODS and EDW, and then into the reporting layer. Okay, and I would like to highlight few issues here from the infrastructure perspective. So typically, your EDW is nothing but Teradata type of system. Okay, where you buy an appliance which will have CPU, storage. Can you please give a small example of data analysis with any of the mentioned tools? I will try to give. First, let us talk from the data integration perspective. You have target. So EWs are typically Teradata type of systems where you buy the entire appliance, wherein you will get CPU, memory, storage, networking, everything as an appliance. Okay, even the software with SUSE Linux, Teradata software, everything will be part of that appliance. And ODS is typically traditional RDBMS, which requires different type of hardware. And for data integration, you use tools like Informatica, DataStage, Ab Initio, where they have their own hardware requirements. So the main point is it requires heterogeneous hardware. So each type of technologies. Okay. So Sandeep, what you have to do is you have to change the resolution. Then it will be good. Okay. So you can go to you can click on the YouTube video, and then here somewhere you will see the resolution details. I think once the CAD is done, you will see the resolution details here. You can change the resolution, and the video quality also will be much better. Okay. So that being said, um, the main thing is the hardware requirements are different, which means we use heterogeneous hardware. If you think about it, it actually poses challenges for your operations. You cannot standardize your operations. Each type of hardware will start throwing you different types of issues. Over a period of time, it will be significant operational overhead. If we can standardize, then we can actually minimize the costs of operations significantly. Okay, so someone, I think Mohammed have asked, can you please give a small example of data analysis with any of the mentioned tool? So I am going back a little bit here. Data analysis or visualization, as I have mentioned to you earlier, the executive management want to see how a particular store is performing over a period of time or compared to other stores. And second use case is, let's say you are buying a lot of stuff from Flipkart or Amazon. As a user, you might want to see how you are spending your hard-earned money over a period of time. That report will help you whether you are unnecessarily wasting money or you are getting most value out of your purchases. That will address some of the wastage of your money. So for the first case where executive management has to look at the report and have to make the decisions, we use tools like Cognos, business objects, etc. For the second use case where there are millions of customers who want to check their buying patterns or spending patterns, we have to use custom visualization frameworks. Example is D3JS, which is JavaScript basic framework. And also if you go to Facebook, if you go to any page and click on likes, you will see the trend, how the pages are being liked. And also I'm an active YouTuber, and I want to see how my videos are performing by going through certain analytics. So I need to get some reports. So those all come under data analysis or visualization. Okay, now let's go forward. So the main takeaway is you need to there will be heterogeneous hardware and different expensive softwares which needs to be supported. Now, if you want to implement this with big data technologies, to get data from relational databases, we can use technologies like Scoop. In some cases it might not be feasible. We don't want to get into that at this time. You can learn through my videos later. You can use Apache Flume or Kafka to get data from streaming logs. If some processing need to be done before loading to databases, again disconnected. So I'm dialing in again. So I'm back. Okay. So here what I'm trying to say is for data ingestion, we use Scoop to get data from relational databases. For streaming logs, we use Flume or Kafka. If some processing need to be done before loading to databases or HDFS, data is processed through streaming technologies such as Flink or Top. Okay, so there are two engines, especially for data processing. Either you can use MapReduce or Spark. We will see disadvantages of MapReduce and why Spark with new programming languages such as Scala and Python is gaining momentum. So before getting into that, when it comes to MapReduce, Hive is the most popular MapReduce based tool. MapReduce works well to process huge amounts of data in few hours. But if you have to do some micro batches where you get data every 5 minutes and process on top of it, then MapReduce is not very good. So now I am getting into disadvantages of MapReduce based solutions. It is primarily designed for large batches, and we cannot use for interactive and ad hoc reporting. Even if you want to generate report on 10 records using Hive or Pig or any MapReduce technology, it will take few seconds. It will not be immediate. It is primarily IO bound, and the processing of micro batches can be an issue. And this third one is very, very important because it actually make the learning curve steep. There are too many tools or technologies such as MapReduce, Hive, Pig, Scoop, Flume, etc. And each of it need to use different syntax and semantics. Okay, so if you want to use Scoop, you have to learn Scoop commands. If you want to use Pig, you have to learn Pig scripts. If you want to use Hive, you have to write Hive queries. And Hive is nothing but SQL. And if you think about it, SQL alone is not good enough in developing application. You have to embed that SQL in another programming language to write an application. So along with this Hive, Pig, Scoop, you might have to use Java or shell scripting or Python or Perl, some other programming language to build applications, which make the learning curve very steep. Also, as it uses I/O to large extent, it is not suitable for enterprise hardware where storage is typically network mounted. Okay, so these are the disadvantages of MapReduce. Spark can work with any file system, including HDFS. Processing is done in memory, hence I/O is minimized. Suitable for ad hoc or interactive querying or reporting. So you can use Spark even for interactive reporting or querying. Streaming jobs can be done much faster than MapReduce. You can choose one programming language and develop everything. Okay, so for example, you can use Scala as programming language. If you have to get data from a remote database, you can use JDBC connectivity, get the data, create Spark-based data structure, and do further processing, and also it can actually run SQL queries embedded as part of it. So you use only one programming language to do whatever you want, and then use other components as and when they are required. It is not the case with MapReduce based technologies. So your development lifecycle will be much effective and smaller when you start implementing using Spark. However, there are some scenarios where Spark can run out of memory issues. If you want to process petabytes of data on a cluster where there is a terabyte of memory, MapReduce can be used, but Spark cannot be used. Spark will start getting out of memory issues. Okay, so only in that case, Spark and MapReduce can complement with each other. But when it comes to a few gigabytes of data processing on regular basis, you can easily transition yourself to Spark. Okay, so now when it comes to implementing using big data ecosystem, you have one set of servers. So there is one. Okay, there is nothing in the chart. Okay, so there are only one set of servers. They are homogeneous servers, and if you see, you can create a ODS and DDW, which are nothing but logical databases on Hadoop, and also you can use the same infrastructure for ETL purpose. So it's not only for data storage, even for processing, you can use the big data technologies such as services such as Hive, Scoop, Spark, etc. to process your data. Okay, so you get data from source systems into big data cluster. There will be no ETL. You can also integrate technologies like Golden Gate, Shaleplex to get data in real time and store it into big data cluster. Also, you can get data in real time using Flume, Kafka, etc., and store into the big data cluster. When it comes to reporting database, still Hadoop or big data clusters are not very sophisticated for reporting purposes. Sometimes, in some cases, we might have to consider lightweight relational database to store processed data, not raw data, only processed data, and report out of it. So if you want to build that, you can have another small reporting database. A MySQL or Postgres is good enough. You don't need to implement Teradata or Oracle, and then you can use your visualization tools to connect to this and get reports generated out of it. And then these are the technologies. Okay, we randomly picked up technologies and we spoke about them. Now we are actually getting into proper structure where how they are organized in different dimensions. So when it comes to big data ecosystem, at the bottom we have the core components where we will have HDFS. I don't know why it is not. Yeah, where you have HDFS, MapReduce as well as non-MapReduce based tools. And then as part of MapReduce, you have Scoop, Mahout, Hive, Woozy, Pig, etc. As part of non-MapReduce, for ad hoc querying, if you just want to query, you can use Impala or Presto. For NoSQL, we have HBase, Cassandra. And for in-memory processing, we have Spark. Okay. And for data ingestion, we have Kafka Flow. And if you want to run analytics out of it, oh my God, this one is again disconnected. It is again disconnected. Let me reconnect. I don't know what's going on. Okay, I'm back. It takes 2 minutes to just dial back in. I don't know why it don't have feature to directly connect through my computer. It would have saved our time significantly. Anyway, so these are different big data technologies. Okay, and each serve a different purpose. And for streaming analytics, we use Storm or Flink or even Spark streaming. And we typically put the data directly to HDFS using these technologies. Okay, and now I'm trying to map based on use cases. If you want to do extract and load from relational databases, we use Scoop. For transformation and load, we use Hive, and also for batch reporting, we can use Hive. For workflows, there is a technology called OZ. For custom MapReduce, we can use Java-based Hadoop Java-based MapReduce programming using the MapReduce APIs. And for real-time scenarios, for just reporting purpose, we can use Impala or even Spark SQL these days. And for real-time data integration or reporting, we can use HBase. Okay, so we can use all these technologies for different purposes. Now let us understand the role of Apache. Each of these are separate projects incubated under Apache. HDFS and MapReduce, Yarn, Hive, Pig, Scoop, HBase, etc. And you can set up your cluster in plain vanilla mode, where you get these jar files. So each of these are nothing but primarily Java-based jar classes which are compiled into jars. So if you want to set up the cluster, for example, if I go back to the Ambari, so if I want to set up HDFS, what I have to do, I have to get jars related to HDFS, deploy on all the nodes, name node, secondary name node, and all the data nodes, and then configure it, and then you are good to go. And I have these many technologies, so I have to get jar files for all these technologies, understand the architecture, and then deploy them, which is very tedious. So if you have to do it manually, and if you have to do it on hundreds of nodes, which are typical in big data, it will take forever. So even if for plain vanilla, people use Puppet or Chef. Advantages, you can set up your cluster with latest versions from Apache directly, but the disadvantages, installation is tedious and error prone. Need to integrate with monitoring tools such as Ganglia, Nagios, etc. That's where Hadoop distributions comes into picture, where they solve most of the problems. They provide easier installation or upgrade using wizards. They have better monitoring, integration with email or SMTP so that alerts are sent through emails, easier maintenance, and many more. Leading distributions include, but not limited to, Cloudera, Hortonworks, Mappa, AWS EMR, IBM Big Insights. Okay, so this is the Hadoop Foundation, Apache Foundation for Big Data Technologies. Cloudera takes these jar files and come up with their own management tools such as Cloudera Manager and agents, which will be running on all the nodes in the cluster. Hortonworks call it as Ambari, Cloudera call it as Cloudera Manager and Cloudera Agent. And then Mapper, these three are the top vendors in Hadoop based clusters. So it got disconnected again, and it will take 2 more minutes to connect back. Yeah, I'm connecting back. So I'm back. Sorry, I don't know. So anyway, if it gets disconnected again, if you see the screen, dial in instructions, that means I'm dialing in. So I don't want to spend time on typing that I'm dialing in again. So just bear with me, or bear with the issue. Okay? Yes, that's correct. And I actually take a lot of trainings for 2 hours, 3 hours, 4 hours at a stretch using YouTube Live and WebEx, and it will never happen like this unless there is issue from my side. It's more of AT&T than anything else. Okay, so these are the different. These are the different distributions we have: Cloudera, Hortonworks, Mapper, AWS, and now certifications. So certifications are very important to get the skills, to learn the skills. Why to certify? To promote skills, demonstrate industry recognized validation for your expertise, meet global standards, stay up to date with the latest advances. So take certifications from vendors like Cloudera, Hortonworks, Mapper, Databricks, etc. Don't go for any certifications from institutions. You will hardly get participation certification. It might be useful to reimburse the amount, but it might not add any value to your profile. If you are serious about certification, learn for free from my platforms and then go for these industry recognized certifications. Okay. There are other advantages also. So when it comes to learning these open source technologies, if you don't have a well-defined curriculum, you will be pulled into all directions without focus on any of the important things. Okay, but if you go through certification curriculum, yes, Kavita, this will be useful for YouTube forever, and you will get the slide from the coordinator. And you can also connect with me on LinkedIn or ping me on LinkedIn or send me an email, and I will take care of it. Okay. So the certifications will actually give you a narrow scope where you will learn few important things at a stretch. If you don't go with certification, you will be pulled in all directions and you will never get anything. If you go with certification curriculum, whether you do certification or not, it's a different story. But if you use a certification curriculum, then definitely within over a period of 3 months or 6 months, you will learn something. And one more thing is, there is a myth that technology changes rapidly. And I don't agree with that. Technology doesn't change rapidly. Programming languages are still relevant today. We have to be capable enough to adapt to the changes in the programming paradigm. Okay, programming will never change. If you are good in programming, you will be adapted to those minor changes. Programming is key. Okay, similarly, MapReduce from the context of big data concepts have not changed for the past decade. It's the same concepts. Only thing is the way it executed changed. There are some improvements happening in that area. So if you understand MapReduce concepts, if you are already a Java developer, and if you understand the concepts thoroughly, you will be able to adapt to Spark now. Okay, so going through the certification curriculum and preparing from the certification point of view without getting distracted will reap a lot of benefits in the longer term. So certifications is very, very important. Resources to learn big data with hands-on practice. YouTube channel, youtube.com/itversity. Please subscribe. There are 900 plus videos. Actually, now I have 1050 videos, 100 plus playlists, 6 certification courses, and we have www.itversity.com launched recently. Few courses added, but we will add more courses in much better form than in YouTube, so that you don't need to move here and there while learning. It will accelerate your learning and you will get much better experience learning through www.itversity.com. Other courses will be added over time. Courses will be either role-based or certification-based, and we'll be working on blogging platform for IT content. So I'm also pretty serious about coming up with blogging platform for IT content. So this is about the resources, and also I forgot to mention about labs.itversity.com and discuss.itversity.com in this slide, because this is a little bit older slide. Since I prepared this, I have launched those two, discuss.itversity.com for support, which is a form-based website, and labs.itversity.com, which will provide you access to a 7-node cluster, which are not included here. Thank you, Hari. Hari is saying that I have already seen your videos from YouTube. It was really worth it. So these are job roles. Typically, Hadoop developer, which is a very wrong term to use. It should be like big data engineer, but still some companies use terms like Hadoop developer, Hadoop administrator, etc. Typically, it should be big data engineer for developer role, DevOps engineer, or big data administrator for setting up clusters, and then big data solutions architect or infrastructure architect for higher level roles. Okay, and now let me cover a little bit about the capabilities of Itversity. Okay, and then I will write a small program to join few data sets, and then we'll wrap up. It might take another 15 minutes, so bear with me. So there is a form. This form is circulated once in a while to be filled by people who cleared certifications going through my content. And if you scroll down, it actually gives details about people who got certified. So there are 120 people who cleared CSC, Spark, and Hadoop developer certification just going through my content, and then other certifications. So we have variety of videos covering variety of topics, and people got benefited through it. Some people successfully transferred to big data career from legacy technologies. Some people are able to they are still application developers, but now they're able to work with either NoSQL databases or Hadoop-based systems as and when it is required. So if you are serious about certification, or from CSC perspective, certification is relevant, we have a proper content on our website. You can reach out to me for particular certification, and I will guide you through. Okay, Kishore, someone have already pinged. I think Divya Pendiala. You got email from her, so you have to just respond to her about the attendance. Okay. So Sandeep is asking. Okay, Sandeep actually given the ID dpendiala@csc.com. Okay, so Sandeep is saying we need few more detailed level tags from the same trainer. I will be glad to do so. even once in a while, if I have to do 1 or 2 sessions of 1 hour or 2 hours for free on a particular topic, I can do that. And also you can connect with me on social networking platforms. I am conducting regular online meetups or live sessions, and you can take part of it. I'll be broadcasting on several social networking platforms, and also I capture email IDs and send emails to the people to remind them. Okay, that being said, let us wrap up with a brief session on Spark. So you can either use IntelliJ or I have always, Mohammed, I have already shared this PPT with Bhagyashree, and she will send it to you. If not, you send me an email, I will share it with you. Okay, so let me finish this. Let me demonstrate about how to develop the program. So here I am using IntelliJ IDE to write Scala-based Spark application. Okay, and typically people tend to show from command line and or from IDE to write the program, but hardly people show how to build the jar file and run on the cluster. So here I will write a program. I will actually compile into a jar file, and I will try to run the jar file on the cluster within 15 minutes. I will not take very long time. Okay, so most of you might be Java developers, and you might be familiar with Maven and Eclipse, right? Or IntelliJ with Maven. So SBT is simple build tool, which is very popular with Scala as a programming language. So similar to form.xml in Maven, we have file called one minute, okay. We have file called build.sbt, where we actually define the dependencies. Where we define the dependencies in Scala syntax. This is all Scala syntax. Don't worry too much about if you don't understand the Scala syntax. So first, you have to install IntelliJ along with Scala, which will come with SBT, and then you click on File, New, Project. If you have Scala and SBT, first time it will come like this. People tend to choose this one, which is not correct. They have to choose Scala and choose SBT and click on Next. Okay, it will take a while, especially if you are doing for the first time. It has to download all the dependencies. So here you have to choose the appropriate Scala version. So 2.10.6 is more popular as of today with respect to Spark application. So I'm using 2.10.6, and then I'm giving project name as CSC demo. Okay, and then use auto import so that when we actually add the dependencies are imported automatically. Okay, I'm opening in this window itself. Here we have the build.sbt. So it is still resolving, so it will take time. Probably under 15-20 seconds. Okay, now it is done. If you want to use, if you want to build Spark applications, so we have Scala version 2.10. So we have to define the dependency of Spark version which is running on the cluster. On our cluster, we have Spark 1.6.2. So we have to Google for Spark core 1.6.2 SBT. Okay, and it will give the, if you go to mbnrepository.com, you will get the appropriate string which you should add as part of build.sbt. If it is not selected, if it is on Maven, make sure you choose SBT here and copy this line and add into here. And when you save, it will auto, because of the auto import is enabled, it will download all the dependencies for you. to build Spark-based applications. Again, it will take a time to resolve all the dependencies. Let's wait for 30 seconds, and I will show you how to develop the application. So while it is being downloaded, let us understand the data model which we will be using, and let us try to develop a simple application where we actually apply a few transformations. So if you search for Cloudera exercise 1, okay, it will give you the data model picture. And I will start from there. So this is the data model. We have two transactional tables, orders and order items. Orders have order ID, order date, order customer ID, and order status. So for each and every order, there will be one entry here. And order items have a few entries for each order. Because one order in Amazon, you can place multiple items, right? And each item might have quantity and product price. By multiplying those two, we get the subtotal. Okay, so we'll be using this to start developing the application. So let's wait for a minute so that this is done. The dependencies are resolved successfully. It is still going on. It should not have taken this long. I don't know why it is taking this long. I think once this indexing is done, I think we should be good to go. Okay, so now it is we got all the dependencies. So there are multiple ways to develop the application. So the directory structure is source main Scala, and here you can actually create the program by saying Scala class. To have main function, we have to choose object here. Why we have to do this and all are clearly explained on other videos on my channel. So one of the area which you can go is, right now there is one live workshop going for some corporate. So you can go to that URL, and I have covered each and every aspect of setting up the IntelliJ with SBT and start developing the programs in detail. So if you are interested, you can go through it, and if you have any questions, you can always ask me in discuss.itworks.com. So this is the playlist. Okay, this is the latest playlist which is still in progress, and it will be done within next 2-3 weeks. Okay, so now to have the main function as part of the Scala, we have to use object. So kind change to object and give the name, whatever name you want. I'm giving it as daily revenue. Okay, and then we can define the main function. Yes, main. So this is the syntax. Okay. Okay, and first, just make sure that you have written the program correctly, and make sure the environment is working by just running this, and it will give us hello world as output. Okay, so it is giving hello world as output, so we can use this. Now Scala has a very good feature called REPL. Okay, so the location of this new project is under my home directory, idea projects, and then CSC demo, and this is SBT project. You can go to Scala console or Scala REPL. REPL stands for read, evaluate, print, and loop. So again, if you go to the videos, you will understand. The SBT console will actually get to the Scala with all the dependencies resolved. So we can start developing Spark programs if we use SPT console and get into Scala. So this is very, very powerful feature. Even Java is trying to implement it as part of the future versions. Okay, so you can use this and you can start developing your program. So to run your Spark application, you need to have something called configuration, Spark configuration, Spark context. To create Spark-based configuration, Spark-based context, first we have to import those things. So here I am trying to import arc.apache.spark.spark conf, Spark context. Okay, now you can create, so the way you define variables in Scala, you don't have to give the data type, it will be inherited automatically. And here I am creating a configuration object, new Spark conf, and we have to give the application name by saying set app name, daily revenue, and then set master local to run the program in local mode or yarn mode. Let me run in yarn mode, so I'm saying yarn client. Okay, don't worry too much about what is these things. I'm just trying to show you how simple it is by using Scala as programming language to join the data and aggregate the data. Okay, then we have to create something called Spark context, which takes this configuration as parameter. Okay, so when we actually create Spark context object, it will create a web service using a port number. Okay, here in the local mode I cannot use. Sorry, in SPT console I cannot use yarn client. Here I have to use local, but in our program we will change it to yarn client. Okay, now I am creating a SC object. Now I want to read data for orders and order items. Already for the data model I have shown you, I have converted the data into comma separated files and stored in this location, research data retail _ db. So here I want to join orders and order items from this directory and join them and get the results. So here I will try to write program very quickly. So I am trying to read the data orders using API called sc.text file because we are trying to read text data, and I have to give the path users IT varsity research data retail _ db 1 minute. Okay, I have to take this call. Hello. Yes, Sadiq, I'm in the middle of a session. I will call you back in 10 minutes. Okay. So I'm back. So here I have to say orders. Okay, and then I have to apply something called map. I have to fetch order ID. So which one is order ID in orders? We have to review the data model here. So this first field is order ID, and our data is comma separated data here. CD orders ls-ltr, and if you do cat, you can see the data is nothing but comma separated. So what I have to do here, rect dot hit comma to int, and then I have to get date from this. Okay, so that I can actually compute revenue. And date is nothing but second field, and it is of date time. I can save it, keep it as string itself, so I don't need to use cast function like this. Order ID is integer, but the input is string, so I have to type cast. But for date we don't need to. So rect dot split of 1. Okay, then let me. So this is orders data. Okay, I think one of the bracket is missing. Okay, now orders is created. The output is nothing but RDD. RDD is nothing but a collection, special type of collection, which is in memory and distributed collection. Okay. Now I need to get order ID and order item subtotal from order items. So order ID is the second field in order item, so that we can join order items and orders, and order item subtotal is fifth field. Okay. So here I have to give order items path. So this is the directory, and then map. Here I would have to give 1 so that we can get the order ID, and then rect dot split comma 4, which is order item subtotal, and this of type double. So I have to use 2 double function here. Okay, and hit enter. I just have to join these two orders dot join order items. Okay. So when we join, it will create a something called tuple, and the first element will be order ID, and the next two elements again will be a tuple, which will have order date from orders and order item subtotal from order items. So I have to get that information so that I can compute the average revenue. So let me run orders join equal to orders dot join order items. Okay, now you see the data type of each element in the RDD is nothing but a tuple, and we have to discard this and get the date as key and order item subtotal as value, and we have to aggregate it. So here I am saying daily revenue equal to orders join dot map. Okay. Don't worry, even if you don't understand anything here, I'm just showing you how powerful Scala is and why it is getting Scala and Spark combination or Python and Spark combination is getting a lot of momentum, especially with respect to big data. I will also show some industry perspective about how these big data vendors are moving towards Spark once this program is done. That's why I'm emphasizing a lot on this. So here you can say reduce by key, okay, and underscore plus underscore. Don't worry too much about the syntax and all those things. You have to look into those videos. And now if I say daily revenue dot collect for each interval. So now you see we've got the data. Each row is nothing but a date and revenue for that date. Okay. Now if I want to get all those comments, so I have written the code, I have validated. Now I want to include this as part of my program. So what I can do, I can type column history and get all the code, all the lines, and then copy these things. Go to IntelliJ, delete this one. Okay. So here I have to import I have to delete this one. Okay. Okay, now the program is developed. I can validate from here also. Run daily revenue. Another 5 minutes. That's it. Another 5 minutes. That's it. Okay, we're not able to copy. It's working for me. Okay, okay. Yeah. Yeah, you are right. It's not working. So I will actually put it in as part of the description in the video so that you guys, let me just take a moment. Okay. So I will put it in the description. So this is the playlist. Okay. So that way you will get it. Okay. Now it is tested here. You can see the data. Okay. Now this is all dealing with local file system, but on Hadoop cluster I have data on HDFS. So I need to make few changes. Ideally, I should make them as arguments. The input path, output path, everything should be arguments. But for now, I will not make them as arguments, but I will make changes that are required. Okay, so that we can run it on the cluster, so that you have idea about how to run it on the cluster. Ideally, we have to make these as arguments. Okay, and also I will be running in the yarn mode. So now, what we have to do is you come out of this by saying exit and then SBT package, which will create a jar file for you. Okay, so I will pause here because we are too much late. So what you have to do is from here you have to get the jar file. So it will give the jar file location here. Okay, and this jar file you can copy to the cluster and you can run it on the cluster. If you go to the playlist which I have shared here, let me show here. I have one video which specifically talk about how to compile and run, which is this one, using SBT and Eclipse Spark execution lifecycle. I took the word count as an example and I have demonstrated, and the same program I have also written here, and I have the code in code snippets which are demonstrated here under dist.github.com. You go to my gist, which is D Gajaraju, and you can see the code. You can get the code snippet from here. And in some of the videos, as part of the description, I have added the relevant URLs to gist and all. But down the line, I will have a complete course where everything is together. Okay, so this is how you typically develop the Spark-based Spark-based applications using Scala as programming language. Scala is very powerful language, and it's an extension to Java, wherein you minimize the amount of coding required by using the functional programming notation of Scala. Okay, it's not extension to Java, but it's kind of parallel to Java, which work in different manner. The syntax and semantics are significantly different from Java, but the execution is happens in JVM itself in the form of Java bytecode itself. So Scala is gaining a lot of momentum when it comes to data processing. If you look at this program, if you have to write the same thing using Java, it will take at least 200-300 lines of code. It's not that easy. Okay. So that being said, now let me also give the industry perspective about why Scala and Spark are more important. So I have spoken about Cloudera, Hortonworks, Mapper. All these are different distributions of Hadoop. If you go to Cloudera certifications, okay, they are distributors of big data, not just Hadoop. Okay, if you click on this, and if you look at the list of certifications, so there is something called CCP Data Engineer, and then there is something called CCA Spark and Hadoop Developer, and CCA Data Analyst, and Cloudera Certified Administrator. And if you go through the curriculum of these certifications which are available today, you don't see Java MapReduce at all. There is no mention of Java in any of these certifications. So Cloudera is pushing Spark and try to, actually they announced last year that they will be moving away from Java as much as possible. Even when it comes to Hortonworks, they are now pushing Spark a lot. So learning Spark is more important with respect to big data technologies. Go through any vendor, Java certifications are not very relevant. You can also see trends on Google, and you can say Java MapReduce and Spark. You can compare these two things. Okay, now Java MapReduce is, okay, this is very generic term, that's why it is. Yeah, computer software. See here, Java MapReduce is actually not picking up. It's pretty much down compared to Spark. So Spark is a lot more important than MapReduce going forward. So try to focus on Spark than MapReduce. If you are already proficient in Java, learning MapReduce also will add good value to your profile. But if you are not very proficient with Java, then I will recommend to learn Scala. Even Java developers, if they want to pursue their career in big data, they have to focus on Scala or Python as programming language. Okay, and when it comes to the weightage in the big data projects, more weightage has to be given to programming language, not Hive, not Scoop, not Spark API, nothing. The more weightage has to be given to either Java or Scala or Python, which are programming languages. Programming languages are key than these APIs and the tools. That being said, I will take few questions here. I know there is a lot of distraction in the in between. AT&T is very poor. I never expected that it will be this poor. Anyway, still I will take few questions before we wrap up today. And thank you very much for joining the session. I am very glad that approximately 200 people actually attended this session. I didn't expect this much turnout. And I will be glad to take more sessions, at least once in 4 weeks. Once in 4 weeks, yes. So someone have mentioned, okay, I think here. Anyway, so I will actually share all the details along with the presentation with Bhagyashri, and you can follow up with her to get more details. And also you can connect me on LinkedIn or Facebook or Twitter, wherever it is, and ping me, and I will be able to share the details with you. Okay. That being said, happy learning, and we'll be also venturing into cloud and many other technologies going forward. I want to make ITversity a one-stop shop to learn any technology in future. And thank you, Priya. Happy Holi to you as well. And have a nice one. Bye. And those who are on YouTube Live, thank you very much for joining the session. If you want to, 1 minute, let me quit this AT&T Connect. I don't know, even the exit is also tough from this. Okay, let me, okay, it is not even letting me to quit. Okay, stop sharing. Okay, now I'm quitting. Okay, so those who are on YouTube, thank you very much for joining the session. And if you like this video, please click on the like button. It means a lot to me. It's very straightforward. You just go to youtube.com and go to the video. Just a moment, okay? Events. And you have the like button here. You can click on it. If you want to share with your friends, just click on share and share on your social networking platform. And if you want to provide any feedback, please leave in the comment section of the video. That being said, thank you very much. Bye.